All right, I'm back with more lattice action for you. So we're going to do a 4-digit by 1 digit using the lattice method. Let's put some random numbers down here. And I'm going to set up my lattice. Now, I told my students to set this up. We want to cut each square in half diagonally like grilled cheese sandwiches. Okay? So, the lattice is a little bit different from the box method. I was almost tempted to write something over here, but I'm not going to because this is the lattice. So, my first digit goes on this side, and then I simply write 1,234 up here. So, first of all, I'm going to multiply 4 times 4. Now, this is the part to keep in mind. This is my ones area. This is my tens area. 4 times 4 is 16. So my 6 goes in the ones area, and my 1 goes in the tens area. Next, I've already used this 4. I'm going to multiply 4 and hop over to that 3, which is 12. The 2 goes in my ones, and the 1 goes in the tens. 4 times 8, or excuse me, 4 times 2 is 8. So I'm going to put my 8 here, and I have nothing to put in my tens column. Next, I have 4 times 1, which is 4, and I have nothing to put in my tens column. So now that I've done all the multiplication, now I just have to do addition. So this little triangle right here is in this space alone. So this does not get added with anything because it's in its own triangle. So it's just 6. The next space is this column right here. So we're using those 2 digits. I'm adding them up, and that's a 3. Next, we're using this column. 1 plus 8 is 9. We're going to move on to that section. 0 plus 4 is 4. And then finally, this is a lone triangle just like this one. So whatever digit I have in here comes out here, which is 0. And then this is actually my product. So my product, we do need to rewrite it. We can't just leave it in the lattice. Is 4,936. I'll check myself really quickly using the standard algorithm. 4 times 4 is 16. Regroup that 1. 4 times 3 is 12. Plus 1 is 13. Regroup that 1. 4 times 2 is 8. Plus 1 is 9. And then 4 times 1 is 4. And I got the same product. All right. Now it's time for the ultimate lattice. This may not be the ultimate lattice, but it's going to be pretty intense. We're going to do a 3-digit by 2-digit. So I'll start by preparing my boxes. But again, I'm just going to cut through diagonally like grilled cheese. I want to make sure I come down far enough so I have space to write. And then I'll write my 2 and my 5 and then 394. And then my first step is 2 times 4, which is 8. I'll drop an 8. Nothing goes in there. 2 times 9 is 18. Here's my ones place and my tens place. 2 times 3 is 6. Nothing for there. I am done with this one. I can cross it out if I want so I don't confuse myself. Next I'll move from 5, or I'll move to the 5. 5 times 4 is 20. I'll drop my 0 in the ones place and put my 2 in the tens place. 5 times 9 is 45. Drop my 5 in the ones, put my 4 in the tens. 5 times 3 is 15. And now I have completed the multiplication. So this part is where it can be tricky. You have to be able to see these columns here and how they're partitioning these pieces. So first of all, this is its own. So I'm going to just drop down that 0. Whatever's in this triangle, you always just write that digit down. So there's my 0. Next, this column, or diagonal column, I don't know what to call that really, this section that I have highlighted, I have an 8, a 2, and a 5 in there. All of those need to be added together. 8 and 2 is 10, plus 5 is 15, and then I need to regroup my 1. I like to put it down here so I don't forget. Next, I have this diagonal section with my 0, 8, 4, 5, and 1 that I need to add up. 0 and 8 is 8. 8 plus 4 is 12. 12 plus 5 is 17. And 17 plus 1 is, oh, not 16. It's 18. And then I regroup my 1. So now we're moving over to this diagonal section right here, where we have a 1, a 6, a 1, and a 1. 1 plus 6 is 7. 7 plus 1 is 8. 8 plus 1 is 9. And then this last piece right here of my triangle, or my grilled cheese sandwich, comes out. And then here's my final product. We have to rewrite that because we can't leave it in the lattice. 9,850. I'm going to put a box around it so I can find my product easily. And I'm going to check myself using the standard algorithm just to make sure that I'm correct. Eight, 18, regroup my 1, 6, 7, 0, 15, 1, 18, 1, 9. 9,000, 850. Fantastic. And this will work for a 5-digit by 4-digit, a 10-digit by 9-digit, whatever you want to use this lattice for, you can.